In this video, which is the follow-up video to the writing trig equations video, I will be solving those same trig equations that we set up from the previous video. I do want to reiterate the definitions of sine, cosine, and tangent, that sine of an angle is equal to the ratio of the opposite side to the hypotenuse side. Cosine, same thing for adjacent hypotenuse, and tangent, same thing for opposite and adjacent. Our goal when we wrote these equations was to write ones that had one unknown so that we could isolate and solve that, and that's what we're going to do in this video. In our first example, we were able to write a trig equation which ended up giving us that the sine of 30 degrees is equal to 3 divided by some variable lowercase c. So now we need to isolate that variable. This is actually a problem that tons of students get wrong. Here's how you solve it. First thing you want to do when we see fractions is attack their denominator. We don't want the denominator there anymore, so we're going to multiply both sides by that side c. Those are going to cancel, and we're going to get that side c times the sine of 30 degrees is equal to 3. Now we're going to divide both sides by the sine of 30 degrees. Now that's going to get us our answer, because these cancel, and we get that c is now equal to 3 divided by the sine of 30 degrees. Now I just want to stop for one moment and point out a pattern, okay? So if you look back at our original equation, this one up here, this orange equation that we started with, and we look at our ending equation, the one that we just ended with, what happened to the side c and sine 30? Yeah, they switch spots, and they always switch spots in this type of an example. So I use that trick all the time, that if I get a variable in my denominator and I'm only looking at a simple ratio like we are with these problems, we can just flip-flop. We switch them out, and it's that easy. Or we can go through, this much math. It's not that much math anyway, but I did want to point out that they just flip spaces, and that's a way to do it fast and get it right. Let's move on to the next problem. So we could, before we move on to the next problem, you could put this into a calculator to get a decimal approximation. I'm not going to do that. That's its value, and we're done. Now, if we knew the unit circle, we actually would know what the sine of 30 is. But we don't know that yet, so we're just going to leave it as is. Okay. Now we're looking at the second example. We need to isolate that variable b. This one's a little more straightforward. People are used to having a variable in the numerator, not the denominator. We multiply both sides by 7. All right, that will cancel that 7 right there and leave us with 7 times the cosine of 35 degrees is equal to b. We could use a calculator and again get the decimal approximation, but that's where I'm going to stop for right now. Problem number 3 that we had the tangent of 40 equals 6 over the variable b. Again, I know the trick. I'm going to use the trick. I'm just going to switch the tangent of 40 and the b and get my answer. So I get that side b is equal to 6 divided by the tangent of 40. Could put that into a calculator and get its decimal approximation if I wanted to. If you don't believe me, multiply both sides by b, then divide both sides by tangent 40. You'll get the same answer. I just did it a little faster. Let's take a short break and remind ourselves of the Pythagorean and triangle angle sum theorems. The Pythagorean theorem relates the sides together. If we're trying to solve a triangle, that'll be super helpful so we don't have to keep doing trig functions. Triangle angle sum theorem, that tells us that all of the angles of a triangle add to 180. All right, that's helpful also so we don't have to keep doing inverse trig functions, which is what I'm about to show you here. So to find missing angles, that's what we had on 4, 5, and 6. We're going to have to get rid of that sign there, right? That's what's giving us the problem. We want b by itself. Right now we have the sine of b. That's no good. We got to get rid of that sign right there, and the same way that we got rid of addition with its inverse operation subtraction, we're going to do the same thing here. We're going to use the inverse operation of sine. Yeah, I know. It's kind of weird. It's just called inverse sine. It looks like sine to the negative first power, and we're just going to do that to both sides here. you'll notice that there's a button on your calculator that does that. It's probably the second or the function button or some kind of shift button and then the sine key. So what happens here is that the sine, inverse sine, and regular sine cancel. And that leaves us with just b equals the inverse sine of 6/10. Now, you see that inverse sines, an inverse cosine, and inverse tangent, they will take a fraction. But regular sine, cosine, and tangent, they take an angle. This is going to help us to find the missing angle there. Now, again, you could have simplified the 6/10 to 3/5. It's the same triangle, so it'll have the same angle. Well, it's not the same triangle. It's a similar triangle with the same angles. But this is where we're going to stop right there. If I had a calculator, I would put that into a calculator and get the answer. All right. In our next example, of course, I used the fuchsia, so I have to use a different color now. We have the cosine of a equals 6/10. We just learned about these inverse functions, and that's exactly what we're going to do here. We're going to use the inverse of cosine, which is a button on the calculator, which will cancel out the cosine on the left, leaving us with just a. And on the right, I'm going to take the inverse cosine of that, which gives me that a is equal to the inverse cosine of 6/10. Now, if you're completing a worksheet, you're going to want to find that in a calculator. There are online calculators that if you type in the 6/10 or whatever the fraction might be, it'll tell you what the angle is. That's not cheating at all. This is only a thing that you would use a calculator for. I had a student ask me, what did they do for these types of things before calculators? Could you believe it that there was a table in the back of a book that was like 20 pages long of just tables of sines, cosines, and tangents of various fractions and decimals and other stupid nonsense? It's the world before the computer existed and the calculator. But anyway, the last example that we have here is one involving tangent. So just like we did sine and cosine, there's of course an inverse tangent that we will use to get rid of the tangent on this side. So that gets rid of that tangent right there. And then we'll just take the inverse tangent of the other side, giving us b is equal to the inverse tangent of 6/8. And again, if we were doing a worksheet, I would put that into the calculator. And if you're using a pretty simple calculator, you want to put the fraction in first, 6/8, and then do that shift tangent, and it'll just do inverse tangent of that value for you. If you're doing something online, you can probably just type in 6/8 in some kind of box and hit a button, and it'll tell you what the angle is. Again, that is not cheating. That is necessary. You could find a table in the back of a textbook, but you probably don't have a textbook, and you probably don't want to look through a table. And it's 2020. What are we doing? All right.